All right, in this example, where we are dividing complex fractions, we want to focus on the fact that there is a bigger division bar where you've got a top fraction and a bottom fraction. And so the idea holds that we just take and rewrite these to be like the previous problems where we had 10 over 9x being divided by this 10x over 9. And anytime you're dividing fractions, you should multiply them as a product of the first fraction and the reciprocal of the second fraction. So this turns into 10 over 9x times the reciprocal 9 over 10x. And then once you've rewritten it as a product, it's essentially one big fraction bar where this 10 times the 9 is on top and then the 9x and the 10x on the bottom, and I can vertically reduce that way. So the 9's vertically reduce. So 9 divided by 9 is 1. 10 divided by 10 is 1. And all that's left on the top, and I hope your brain doesn't say nothing, nothing's left. Well, there's a 1 times a 1, so the top has a 1. I have so many students that turn it into a 0 or just a gap. There is a 1 up top, and then we have an x and another x. So that's going to give us an x squared in the denominator. And now if you didn't like the way that was written, you could have taken this middle area here and made it a 9 times 10 over the 9x times the 10x. Maybe that would have helped your eyes see that the 9 divided by the 9 reduces to a 1, and the 10 divided by the 10 reduces to be a 1, where just the x's are left, and resulting in a 1 times 1 on the top and x squared on the bottom. Either way, the result was 1 over x squared. So there's a top expression and a denominator expression. And so our job is to simply separate them right here. And I would look at it as if we were just seeing one of those previous problems where it was 10 over 9x squared divided by 5 over 2x to the third. That's all this means. So when it looks perhaps stressful, it's just a division of two rational expressions as we've done before. And anytime we're dividing rational expressions, you're supposed to just take the second fraction and rewrite it as a product of the reciprocal. So you leave the first fraction alone, 10 over 9x squared, and then you multiply that by the reciprocal of the second fraction, so 2x to the third over 5. And then what I do is I treat these as, once it's written as a product, it's just really one fraction bar with a product of your rational expressions. So it's really, you could rewrite it to be 10 over 5 on the bottom, if I just move the 10 and the 5, times 2x cubed, and then the 9x squared. So all I did was rearrange the multiplication where this 5 just traded places. So that way I can see vertically I can reduce, but I didn't have to rewrite it. I could have just done it here. The 10 and the 5 reduce. 5 goes into 10 twice, just like I'm going to do here. So this would have been a 2. Anyway, this is 5 goes into 10 2 times. So divide top and bottom by 5. And there's just a 2 there, 2 over 1, if you will. And then the 9 and the 2 can't reduce, but the x squared and the x to the third. I can reduce 2 x's from the top and the bottom with 1 x remaining. And again, I could have done that over here in the middle. I could have crossed out that 3 and turned it into a 1, and those x squareds could have been gone. And then you multiply what's left, either which way you did it, straight across. So you take 2, these multiply by the 2 and the x to get 4x. And on the bottom, I have 1 times the 9 to just get 9. So the result of division of these complex fractions is 4x over 9.